Rational zero theorem. Let P be a polynomial function with integer coefficients in standard form. If P over Q in lowest terms is a root of P of X, then the rational zero P over Q equals P is going to be the factors of the constant term and Q is going to be factors of the leading term. So to understand it better, let's actually use a polynomial to illustrate this. So here we're given the polynomial function and asked to list all possible zeros. So for this polynomial function, P, the top number, stands for factors of the constant term. The constant term is always the term in the back, the last term. It's the term that does not have a variable. Q is going to be factors of the leading coefficient. The leading coefficient, when it's in standard form as such, standard form mean highest degree down to the lowest, degree 4, 3, 2, and the constant. So when it's in standard form, the term with the highest degree, that's called the leading term. And the number in front of the variable is called the leading coefficient. So in this example, P over Q, P is going to be your constant term, which is your back end term. And Q is going to be your front end term of -2, okay? Now actually with the rational zero theorems, you can just write P over Q as both positives, because when you write out your factors, you have to write out both the positive and negative anyway. And you'll know what I mean as we move forward. All right, so let me erase my screen here real quick. Okay, so again, to list the possible rational zeros, we're going to use the P over Q. And as I said before, P is going to be your back end term, and Q, the bottom number, is going to be your front end coefficient, or your leading coefficient. The next step is you want to list out all the factors of the top number and all the factors of the bottom number. So in case you forgot what factors are, it's the numbers that when you multiply them will equal a certain number. In this case, it's 18. So we want to know what are the numbers when we multiply will give us 18. Well, the first thing I can definitely think of is 1 times 18. Another possibility is 2 times 9. So this particular number has a lot of factors there. And then 3 times 6. Okay. Now the bottom only has just the 2 factors, and that's 1 and the number itself. So 1 times 2. All right, now you don't need to write it like that. I just did this to make a point that 18 has 1, 2, 3, 4, 5, 6 factors, and 2 has 2 factors. Okay, so let me go ahead and erase that, and we're going to write those factors with both the positive and the negative, plus or minus. That is how we write it with the rational zero theorem, because you are trying to list all possible zeros that there might be. So let's go ahead and do that. There it is. And now once you have listed these factors here, and by the way, normally they are listed in order. If you look in your textbook as well as your homework online, you'll notice that is usually the standard way of writing out the factors is writing them from least to greatest. So again, factors are just those numbers that when we multiply two numbers together, that they're going to equal that number. So you list all of those possible factors. So the next thing we're going to do is we're going to match each factor. So the next thing, we're going to match each factor of the numerator with each factor of the denominator. So what do I mean by that? So on top we have 1, 2, 3, 6, 9, and 18. So we're going to write all those over a denominator of 1. And then we're going to write all those numbers again on top, but this time with a denominator of 2. All right, so these are really all the different possible rational zeros here, but we don't want numbers to repeat themselves. So let's take a look closer at what we have here. So basically, you should see that all of these numbers over 1 is just simply the number itself. So in other words, 1 divided by 1 is going to equal 1. 2 divided by 1 is going to equal 2, and so forth. So what we're going to have is we're going to have these possible rational zeros: 1, 2, 3, 6, 9, and 18, because any number over 1 is that number itself. Now let's take a look at this group over here. We need to make sure that there's no factors that repeat themselves. So let's take a look at the first one, 1/2. We don't have 1/2. And by the way, this is our list of possible zeros, and we're going to add to that list. So 1/2 is not on the list, so let's go ahead and add that, plus or minus 1/2. And we always write it with plus or minus. All right, we got that. How about 2 over 2? 2 divided by 2 equals 1. We already have that on our list, so we don't want anything that repeats itself. Okay, next, 3/2. 3/2 is not on our list, so let's add that to our list. So it's going to be plus or minus 3/2. 6 divided by 2 equals 3. We already have that on our list, so we don't repeat any numbers. 9/2. 9/2 is not on our list, so let's go ahead and add that to our list of possible rational zeros. And lastly, 18 divided by 2 equals 9. We already have that on our list. So there you have it. We have there all our list of possible rational zeros there. And that's simply how you find it. You're just writing a combination of all the possible zeros. Just make sure that none of your zeros repeat themselves. Okay. All right. So let me go ahead and again list them. Here are all the possible rational zeros.